Welcome to the Geometry live, or I guess a recorded session for the week. It is the week of October 13th. This is also, can you believe it, we are in week 9 of our assignment. So when you go to do your assignments this week, make sure you're looking in the folders that have week 9 next to them. I do want to start with a warm-up this week that's more reviewing a vocab word that we've talked about in the past. And that is, what is a bisector in geometry? So I want you to take a moment to write down in your notebook what bisector means in geometry. And if you need to do a quick review, you can do a quick web search. So just a reminder of how much information is available at your fingertips. If you don't remember what this word is, go ahead and type in what is a bisector in geometry. You will need to type in geometry in the search. Otherwise, you might get a different kind of definition that is not related to math. So go ahead, take some time to do that. If you need to click pause so that you can have time to do that, please do that now. So bisector, what does bisector mean? What does bisector mean in geometry? So a bisector is something, a bisector is a line that divides something. It can be an angle, it can be a line, it can be a segment. So that something can be a segment, it can be an angle. So a bisector is a line that divides something into two equal parts. So let's look at those two segments and angles that a bisector might bisect. So if we've got I'm going to change font or colors here. So here's a segment, and we'll call this point A, point B. A bisector is a line that divides something into two equal parts. So if we have a bisector come in, it is going to divide, oops, that's not quite down the center there. It's going to need to move a little bit that direction. So it's going to divide it into two equal parts. And remember, we can show, so this would be the bisector. We could show that those segments are congruent by putting little ticks in there. That would show that, and we can call this point C, that would show that AC is equal to CB. So that's a bisector. We can also have an angle bisector. So if we have an angle here, and let's change colors again really quick here, and we'll throw in an angle bisector. It's going to come in and divide. The bisector would be in green here, and it would divide that angle into two equal angles so that they would have the same angle measurement. So that's what a bisector is, and we're going to be talking about bisectors this week, so I did just want to review what that term means. So what are we doing this week? We are completing 3 sessions in Unit 2. We're wrapping up. We've almost wrapping up session 2. We're going to do session 8, which is all about isosceles and equilateral triangles and looking at the angle patterns that occur in those types of triangles. Bisectors and bisectors of triangles will be introduced in Unit 2, Session 9, and then Unit 2, Session 10, we're going to look at medians and altitudes of triangles. So also just a heads up that the Unit 2 test is coming next week, so you can start reviewing for that. That will be next week, not this week. Alrighty, isosceles triangles. Remember, in isosceles triangles, make sure you're taking good notes as you're watching this recording. It's going to help you this week as you do your assignments. So isosceles triangles have two congruent sides or legs. So remember, that's what an isosceles triangle is. and we see those congruent legs, we've got a tick here and a tick here, and that lets us know that this is an isosceles triangles. So something that we haven't talked about is the base angles of an isosceles triangles. These two angles that are opposite the congruent legs are going to be congruent. So something that's a cool pattern with isosceles triangles is that you're also going to have two congruent angles, and those congruent angles are not just going to be anywhere. They're always going to be opposite those congruent legs. So the angles that are congruent will be opposite the congruent legs. So let's apply that. So here, let's look at what type of triangle we have. I see that we've got two congruent legs because of that tick. So I know this is an isosceles triangle. And the directions ask us to solve for x. Well, how can we solve for x? Well, what do we know about these two angles? What do we know about these two angles right here, based on what I introduced to you on the previous slide? Well, these angles are opposite the congruent sides. They're opposite the congruent sides, and we just learned that those angles opposite the congruent sides will also be congruent. So we can set these two equations equal to each other because we know those angles are congruent. And then we're just going to solve for x. I need to get all my x's on one side of the equation, so I'm going to subtract x from both sides to get 30 equals x. Boy, that was easy. And then that's all that you were asked to do here, but sometimes you might need to go as far as it might say now, find the measurement of an angle, where you would actually now have to plug the x value into the equation to find that missing angle. All right, here's another question. Find the measurement of angle 1. So that is this angle right here. We're trying to find that angle measurement right there. How can we do that? Well, what kind of triangle is this? Got two congruent sides, so we know this is an isosceles triangle. We also know that when we are dealing with isosceles triangles, that these two angles then would have to be congruent. These two angles would have to be congruent. So we can figure out what those angles measurements are, can't we? We know that 54 plus x would all have to add up to 180 degrees. I know both these angles are going to have the same measurement, so I can label those angle x. Clean up the equation. We've got 54 plus 2x equals 180. Subtract, we're just doing some algebra now. Subtract 54 from both sides. We get 2x equals 180 minus 54. 180 minus 54 is 126. Last step is to divide each side by 2. We get x equals 126 divided by 2, 63 degrees. So that means that each of these angles are 64 degrees because it has to be congruent. So we're not done yet, are we? This is 64, oops, 63. I don't know why I said 64. If I said that, apologize, that should be 63. So what can we, how can we solve for angle 1 now? How can we solve for angle 1? Well, remember, we know that in a straight line, like this one that I highlighted in purple, that straight line will have a total of 180 degrees. So we can set up an equation now to solve for the missing angle measurement of angle 1. We can say that 180 degrees equals, whoops, hold on a second, I'm going to start writing that weird. If we take 180 degrees and subtract 63 from it, it should give us the measurement of angle 1, right? So 180 minus 63, and we get 117, measurement of angle 1. So we used what we learned about the angles in isosceles triangles, and that there are two sets of congruent angles opposite the congruent sides to help us solve this. Moving on. This is going to be in your assignments this week. So this question here comes from your assignments. Every year students kind of struggle with this problem, so I thought we would do this one. It kind of will be your freebie for this week. I believe this comes from the Unit 2 Session 8 assignment, the graded assignments. So if you're watching this, taking good notes, you will have a freebie this week. So it's a good way for me to tell who's also watching the entire recording. You will see this exact problem and we're going to go through it together. So the problem says find BT. So we need to find this side here, the length of this side BT that I just highlighted in purple. We're told that side AC is parallel with the ground. So we're told that this side here is parallel with the ground. Alrighty, so we have a set of alternate interior angles and a set of alternate exterior angles because we have a set of parallel lines and a transversal that created some angles. So we know if this angle here is 40 degrees, this one must also be 40 degrees. 40 degrees. And we also know that from here to here is 80 degrees. And from here to here is 40 degrees. So can you tell me what this angle measurement must be from here to here, that piece of the 80 degrees? It must also be 40 degrees. So from here to here and here to here, these are the same angle measurement. They're both 40 degrees. So what do we know? What type of triangle has two angle measurements that are congruent? What type of triangle has two angle measurements that are congruent? An isosceles triangle. And what do we know about the legs opposite those congruent angles? They have to be congruent. So we are given, so we know now that, let me try a color we haven't used yet. This side leg and this side leg must be congruent. We know that this side leg and this side leg, because they're opposite the congruent angles, they must also be congruent. So we are working with an isosceles triangles that has two sets of congruent legs. And this side already is labeled for us as 2.4 miles, which means this leg must also be 2.4 miles. So we found the side BT must also be equal to 2.4 miles. Now the important thing is that you are explaining how you arrived at that answer, is what we just did when we went through this problem. So that's your freebie for the week. I'm going to go to the next slide now. And we are going to be, there we go, talking about bisector right now. So remember, a bisector is something that divides something into, whether it's a segment or angle, into two equal congruent parts. And we already talked about that in the warm-up, so I'm going to skip that. So a perpendicular bisector. So here we're adding the word perpendicular to the term we've been talking about today, bisector. We're adding perpendicular. So what is the definition of a perpendicular bisector? So what is perpendicular? Do you remember what perpendicular means? It intersects at 90 degrees. That's what perpendicular is. So a perpendicular bisector is going to be a perpendicular line or segment that passes through the midpoint of a line, because it's got to divide that line or segment into two equal parts. So a perpendicular bisector divides a line segment into two equal segments, and then the intersecting point of three perpendicular bisectors is called a circumcenter. That's really what perpendicular bisector is, what I want you to focus on. So here's an example of a perpendicular bisector. It would be this line right here that I highlighted in green, because it intersects this line here, this segment, in two equal parts, and it does so at a right angle. So we've got that right angle in there. So that's a perpendicular bisector. The perpendicular bisector theorem states, and you're going to be using this is going to be a tool, the perpendicular bisector, the properties that it has is going to be a tool to help you solve problems. So the perpendicular bisector theorem states that any point on the perpendicular bisector of a segment is equidistant from the endpoints. So let's look at that and see what that means. So here we've got our perpendicular bisector. I'm going to highlight it in green, and it's intersecting that segment AB, at a right angle, and we can see from the ticks that it created two equal parts of the segment, so that AD equals BD. So what is interesting is when you have a perpendicular bisector and it intersects a segment, if you are to draw really a triangle out to any point, those legs would be the same. They would be congruent. So let me highlight and create a triangle, because really what you're focusing on this week is triangles. So let's draw this triangle here. So because we've got a triangle with a perpendicular bisector going through it, we would know that the legs of the triangle here are going to be congruent. Because of this perpendicular bisector, because we know it is a perpendicular bisector, because these ticks let us know that this segment here not only intersects at 90 degrees, but cuts it into two equal parts. Well, now these two legs of the triangle are also going to be congruent. That's the perpendicular bisector theorem. Let's put it to work. Alrighty, so here we would want to solve for x. So what do we have here? We've got this line that's going through the middle of the triangle. It intersects segment MO at a right angle, and then we have two congruent pieces that it bisected. So we have a perpendicular bisector because it bisected segment MO with a right angle, and also it created two equal parts. It bisected it. So what did we just learn about what it does to the other legs of the triangle? These legs are also going to be congruent. So because of that, we could set that equation, those two sides, equal to each other and solve for x. So let's go ahead and finish that out. Subtract. We're going to get all of our x terms on one side of the equation by subtracting 3x from both sides. We're left with negative 2 equals 3x minus 14. We need to add 14 to both sides. I'm running out of room, so I'm going to continue up over on the right here. Negative 2 plus 14, that's 12, equals 3x. And then we just need to divide each side by 3. And I get x equals 4. So you could check your work by plugging in the value we just got for x into both of our equations, and we should get the same number. 3 times 4 is 12. 12 minus 2 is 10, so that side is 10. 4 times 6 is 24. 24 minus 14 is also 10. So those two sides should in fact be congruent, based on the perpendicular bisector theorem. Okay. So I'm going to move on to the next slide. If you want to click pause so that you can finish up taking good notes, that would be a good time to do that. And then click play when you're ready to jump back in. Alrighty, so we talked about perpendicular bisectors. So now we're going to talk about perpendicular bisectors within triangles, which is really what we just did on that last slide. So look at the right side, because this is something we've already talked about. Perpendicular bisector. A perpendicular bisector, remember, will pass through the midpoint of a side, and we know a midpoint is really the same thing as what a bisector does. It divides something into two equal parts. So a bisector passes through the midpoint of a side at right angles. So we can have 3 different perpendicular bisectors in every triangle, because we have 3 sides that we can bisect. So it's got to bisect at 90 degrees, and then it has to also divide the side it intersects into 2 equal parts. And we can see that on each of these perpendicular bisectors. Another type of another type of line that we can intersect our triangles with is an altitude. So an altitude is a little bit different than a perpendicular bisector. So an altitude is going to pass through a vertex. So remember, a vertex is where your points or your sides come together. That's a vertex, what I just highlighted in green. These are our vertexes. An altitude passes through the vertex, and then on the opposite side of the vertex, it has to end at a right angle. It's going to intersect the opposite side at a right angle. So again, we're going to have 3 altitudes for each triangle because we've got 3 vertex. We start at a vertex, we end at the opposite side at a right angle. So that is what an altitude is. you start at a vertex and then we intersect the opposite side at a right angle. So make sure you copy down the two things that each of these types of lines do. So a perpendicular bisector is a little bit different in that it has to go through a midpoint, and it has to, on the opposite side, or it also intersects at a right angle. So both these have right angles, it's just different in, one is going to be a bisector, the perpendicular bisector, and the altitude just has to go through a vertex. All right, so let's make sure we understand that. Altitudes and bisectors look very familiar, but they are not the same. They are not the same. So let's review the difference really quick. An altitude is not going to, when it intersects its sides, the opposite side, so it starts at a vertex and then it has to intersect at a right angle. Does it divide the side into two equal parts that it intersects? It does not. So that's what's different. An altitude does not divide the side that it intersects of the side of the triangle. It does not divide it into two equal parts, where a perpendicular bisector does. So they both intersect at 90 degrees, but a bisector is going to bisect that side of a triangle and divide that side into two equal sides, where an altitude will not. An altitude will not divide that side of the triangle into two equal sides. So that's what's different. So here we've got, this is going to be our median, right? Or I'm sorry, our perpendicular bisector, because it divides it into two equal parts. So this would be our perpendicular . So make sure you have what's different about each of these. And then medians, we talked about, goes from the vertex. So I'm going to skip that. Oh, median. We didn't talk about medians yet, did we? No. Where's our slide on medians? Okay, here we haven't talked about medians yet. This is a third type of line that we can talk about inside of triangles or within triangles and intersecting triangles, is the median. So the median is going to start at a vertex, just like our altitude, and then it's going to, on the opposite side of the vertex, it's going to connect and break that side of the triangle into two equal parts. So it's going to have similar properties as a perpendicular bisector. So a median has similar properties to both altitude and perpendicular bisectors. So the median is the same as an altitude because it starts at the vertex, but then it does not have to intersect at a right angle. It does not have to intersect at a right angle. It will, when we go across and we start at the vertex and we intersect the opposite side of the triangle, it will break or will divide that side into two equal parts. So that midpoint side is the same as the perpendicular bisector. So this is a median. It's got some characteristics of both. So we've talked about three things so far. We've talked about perpendicular bisectors, medians, and altitudes. And we're going to finish up here with a comparison of all three of them. So we talked about some things that they have in common. So some of them have intersect at right angles. Some have a midpoint where it breaks the side into two equal parts or intersects that side into two equal parts. And then some start at vertexes. So let's make this cool little comparison of what two aspects each will have. So each of them will have two out of the three aspects. So the perpendicular bisector, does it have right angles? Yes. Remember, it intersects the sides at right angles. Does it intersect at a midpoint or divide the side into two equal parts? The perpendicular bisector, it sure does. Does it intersect a vertex? It does not. So the perpendicular bisector will have right angles and divide the side of the triangle into two equal parts at a midpoint. What about a median? What about a median? That's the one we just talked about. So the median, right here, it goes from the vertex to the midpoint. It does not have to have right angles. And then last but not least, we talked about altitudes, where altitudes always intersect at right angles and at the vertex. So that was, altitudes was back there. Vertex to right angle. So have this chart will help you as you work through your problems this week, and that's where we're going to stop for today. Good introduction of everything. And then we are ready for a key phrase assignment. So this is the week of October 13th. And I want you to explain the difference between, we'll have, how about altitudes and medians. So we talked about 3 different things, but let's, I want you to focus for the key phrase. Tell me the difference between altitudes and medians. And the best way to describe the differences between something is just to define them. And that's going to do a good job of then telling me the difference between altitudes and medians. So have a great rest of your week, and let me know if you need any help on anything as you work through this week's assignments. Remember, I gave you a freebie in this recording on one of the problems you're going to see this week. So if you watch the entire recording, you will have that freebie.